On April 13th, 2029, a very large asteroid, at least as far as near-Earth asteroids are concerned, is going to pass within 32,000 kilometers from our planet's surface, 1/10 of the distance from Earth to the Moon. And yet, in spite of this incredibly close call, NASA has recently announced that they are ruling out any possibility whatsoever of this asteroid colliding with Earth based on extremely detailed studies of its current orbital trajectory. That's very reassuring, isn't it? Well, yeah, it is, and in my opinion, it's also extremely irresponsible. The reality of Apophis and virtually any near-Earth asteroid is far more complicated than this, and this is pointed out by Professor Brian Cox in his famous book, Wonders of the Solar System. Quote, "There are asteroids with orbits distorted from the harmless majority that stay away from the inner solar system, bringing them near enough to Earth for concern. We have cataloged thousands of these, but nobody can be sure how many are out there or what effect a subtle change in the orbit of one we know about would be. Is Apophis vulnerable to a subtle change in its orbit? Yes, it definitely is. And if it changes its orbit even slightly in the next 7 years, it would go from an asteroid that has been ruled out as any threat to our civilization to something that would bring a catastrophic event to our planet. And we're gonna cover just how easily something like that could happen. Hello, YouTube. I'm the Angry Astronaut, and this is... Now, what you're looking at right now is the data that was collected by the Neowise mission, which originally was the Wide Field Infrared Survey Explorer, or the WISE, which was a space telescope designed to survey the sky in the infrared, detecting asteroids, stars, and some faint galaxies. And it did so until it completed its primary mission in February of 2011. However, in December of 2013, it was determined that it might be a good idea to reactivate this telescope to try to detect near-Earth objects. And as you can see, the ones that are illustrated in green in this animation are these near-Earth objects, and there are hundreds of them. During its primary mission, this telescope detected more than 158,000 objects, 34,000 of which had never been discovered previously. Now, it should be very clear up to this point that the solar system is absolutely packed with these objects, but space is a very large area, obviously, and so the odds of one of these actually colliding with our planet is very, very low. That having been said, though, Apophis is sort of a unique situation. It is actually passing closer to the Earth than any large near-Earth object in recorded history. That's right, we're talking 5,000 years of recorded history, and this asteroid is going to pass closer than any asteroid of considerable size. That is very concerning, especially given what this thing could do if it were to actually hit our planet. 50,000 years ago, a nickel-iron asteroid, or meteor, roughly 50 meters in diameter, impacted an area outside of Flagstaff, Arizona. The force was 150 times greater than that of the atom bomb that destroyed Hiroshima, about 2.5 megatons. And by the way, I personally took this footage. Thanks to my supporters, I'm able to make these kinds of trips, so if you'd like to check out the description and find ways to support my channel to keep this content coming, please feel free to do so. Okay, enough self-promotion. This massive crater is over 1 kilometer wide and more than 150 meters deep. It is utterly colossal, and it was created by a 50-meter asteroid that generated a 2.5 megaton explosion. Now, let's compare that to Apophis. As you can see right here, we are looking at a monumental difference of many magnitudes over what created Meteor Crater. We're talking something hundreds of meters in diameter, not 50, and something that would create an explosion of an estimated 1,200 megatons, not 2.5. The destruction would be nothing short of cataclysmic. For a quick illustration, well, sorry, San Francisco, I've decided to target your city and have a look at the devastation. Everything within the green circle would be incinerated. We're talking every tree, everything made out of wood would catch fire. Anything even closer to the impact zone would suffer even more cataclysmic damage, and just about everything would catch on fire, including skyscrapers. We're talking the entire city of San Francisco, plus Oakland and the surrounding areas, would be burning for months, if not years. And the surrounding area would be so devastated that even getting emergency equipment into the region would be a very, very large challenge. Now, if this were to hit the water instead, you would be looking at a pretty substantial tsunami. Certainly nothing as bad as the one that wiped out the dinosaurs, but nevertheless, we're talking 30 to 40 meters in height at least, something very comparable to the tsunami that killed hundreds of thousands of people in Southeast Asia and many, many thousands of people in Japan a few years later. Something like this would be very damaging, not only to the planet, but also to the environment. A 1,200 megaton explosion wouldn't create a multi-year nuclear winter or anything like that, but it would definitely impact the climate for at least 1 or 2 years, similar to the Mount Tambora eruption of 1815 that created a year without a summer in 1816. No doubt this would create some significant food supply shortages across the planet for a while, but not something that would have worldwide devastating consequences that would lead to the deaths of many hundreds of millions of people like we're talking about with much larger asteroids. Still, this is nothing to laugh at. But why am I being such an alarmist about this? Well, because in my opinion, I'm not being an alarmist. If we're talking about an asteroid that is passing closer than any threatening asteroid or dangerous asteroid has come to the Earth in recorded history, this is something to be taken very, very seriously, especially if something happens to create even a subtle change in this asteroid's orbit. And those subtle changes happen all the time. For one thing, there's something called the Yarkovsky Effect. Now, believe it or not, solar radiation can actually change the speed and trajectory of small asteroids. For asteroids that are spinning in a prograde direction, that is to say, spinning in the same direction that they're orbiting, the asteroid gets a push in the direction of its orbital motion. If it's rotating in a retrograde direction, then it pushes it backward. It slows it down, in other words. This makes projecting the exact trajectory of an asteroid a lot more complicated. And if you're talking about an asteroid that's going to come within just a few thousand kilometers of our planet in the next 7 years, even a small change can make a big difference. But sunlight isn't the only factor at all. Here in a few years, we're going to have the NASA DART mission. It's already been launched, of course, and this is going to be using a kinetic impactor to determine how much it can change the orbital trajectory of the smaller of a 2 asteroid system, the Didymos system. It will hit the smaller of the 2 asteroids to see how much it changes from the kinetic impactor striking it. Now, this is very good when we're talking about experimenting with various ways to deflect asteroids and to protect our planet. But here's another lesson that we really need to learn from this. What a kinetic impactor can do to an asteroid, another object, a smaller meteoroid that we are unable to detect, can do the same thing to Apophis. It wouldn't take a very large rock at all in order to make a substantial change in its trajectory. And once again, we're talking a few thousand kilometers over the course of 7 years. Even the mildest change in trajectory could easily put Apophis on a collision course. And it's not just meteoroid impacts either. It can be something as innocuous as interplanetary dust. Even that can change the trajectory of something as small as Apophis. This is something that we really need to be taking seriously, not only for 2029, but also for 2036. Currently, we project that Apophis is going to be a very long ways away from Earth in 2036 when it makes its next approach, assuming that the gravity of our planet has the same impact on it that we project that it will. However, there are other planetologists and other astrophysicists who are beginning to think that this could be a totally different situation. They're talking about something called a gravitational keyhole that would impact the orbit of Apophis much differently than what we were thinking originally. And if this were to take place, we're looking at a collision in 2036 instead of 2029. Now, NASA has completely ruled that out, at least officially, but unofficially they acknowledge that there's a chance of 1 in a little over 100,000 that something like this could happen. Yes, a very small chance, but nevertheless, a hell of a lot better than winning the lottery. And do we really want to be playing these kinds of games of chance with the future of our planet, especially if we're talking about a 1,200 megaton explosion? And here's another disturbing scenario. Another proposed method of deflecting a dangerous asteroid is to use something like a gravity tractor depicted here. It merely uses the gravitational mass of a satellite to deflect an asteroid. Yes, this seems ridiculous, but the fact of the matter is, something with a mass as small as a probe of, say, 10 or 20 tons can actually impact the trajectory of an asteroid as large as Apophis. Not much, but over the course of 7 years, the impact can be gigantic. So what's my point? It would only take an encounter with a relatively small object. In other words, you wouldn't even need to have a collision, but rather just an encounter with a relatively small asteroid that we can't detect, and its gravitational influence would cause a modest change to Apophis's trajectory. And once again, if you're only talking about a few thousand kilometers, a modest change can be cataclysmic. So what should we be doing right now? How do we react to these possibilities instead of just saying that we rule them out and it's so unlikely that we shouldn't even give it any thought? Well, when Apophis is concerned, we really should do everything we can to push it as far away from our planet as possible, proactively. And we can do this. We have the technology. I've already described a couple of processes, but there are others, very, very subtle ones. For example, laser ablation. You hit the correct side of the asteroid with a laser, and the photons, along with the evaporation of any ice that might exist on the asteroid, that alone can change its trajectory in a very precise fashion, slowly pushing it away from any potential future collisions. And that's just one of many ways that we can proactively protect our planet. And it's not just Apophis. There are still quite a number of dangerous near-Earth objects that we have yet to detect. And on top of that, there are also comets that come in from the outer solar system, from the Oort cloud, the Kuiper belt, and elsewhere, that could also present a tremendous threat to our planet. We need to have a comprehensive asteroid and cometary defense system in order to keep our planet safe from a cataclysm like Apophis could represent. And yes, perhaps the chance of Apophis actually impacting are pretty low, but that doesn't mean that we should be completely ruling it out, and it doesn't mean that just because we dodge this particular bullet, we should be so cavalier about future threats. Instead, we should learn from this experience as we hopefully literally watch it pass harmlessly by through our night sky in 2029. Smash that like, hit that subscribe, and until our civilization starts taking this threat a lot more seriously, I urge all of you to stay angry about space.